Hi, Henk Akkermans here, Supply Network Dynamics, Chapter 7, clip number 4, Workforce Allocation Flows. So we have one workforce, but it needs to be allocated to 3 different stages. And yes, in reality, often these different stages are different people with different skills. Here we toss them all together on one big heap, but still the work, and which is partly also true in the reality. Many people do conduct the different activities in the different stages. Nevertheless, how do we allocate capacity here? Well, basically what we do is we calculate the amount of work that has to be done and then allocate capacity proportionally. This is also called the squeaky wheel gets the oil algorithm of capacity allocation. So we've got 3 pieces of work, tasks to be developed in stage 1, 2 and 3. These are ghost copies of the main flows that we saw in clip 1. And they all together, they are the total amounts of work to be done. In what you get is that in, for instance, the capacity allocated to stage 1 is really the tasks to be developed in stage 1 divided by all these 3. Well, not quite actually, because only once they have started. If they have not started, as you have here in stage 2 and stage 3, then this value becomes 0, because you do not need capacity for a stage that hasn't started. These are Boolean values, as we saw in clip number 3, that become 1 as soon as that stage has officially started and stay at 0 when it has not yet started. This total, all this here is a value between 0 and 1. So it's basically the percentage of the total capacity that has to be allocated to stage 1 that you multiply by the total capacity available. And that's the 4th level here. And the same you do for stage 3 and 2. Here it is the total capacity times how much you need to be done, how much you need in stage 2. And also in stage 3, the total capacity available times how much you need to do in stage 3. And that's basically it. And these capacity allocated then go back into the model and drive, here you see their copies, drive the main flows as we defined them in clip number 1 for the actual development work. And they then become the constraints on the side of the outflow here. And so we are back to the beginning of the model. And that's the whole model.